Gas stoichiometry practice sheet. For these first two questions, it's assumed to be at standard temperature and pressure, even though this one doesn't say it. This one is at STP. This one's also telling you it's at STP. So these first two are going to be very much like the first worksheet that you did, where you did a full-out stoichiometry problem and solved for the amount of a substance that would be made. And notice here it says, and an excess of hydrogen. That means it doesn't matter how much hydrogen you used because you had plenty to react with this amount of the other substance. So for the first two, just do out your stoichiometry the way we've been doing. Once you get to number 3, however, this is where it's going to get a little different. Here's where you're going to put stoichiometry and the ideal gas law together. Now, this does say 85 degrees Celsius here, so I'm just going to go ahead and bring that over. So what we're going to do here, it says how many liters of water can be made from 55 grams of oxygen gas and an excess of hydrogen at a pressure of 12.4 atmospheres and a temperature of 85 degrees Celsius. So what we're going to do, because this is not at standard temperature and pressure, I can't assume that it's 22.4 liters for 1 mole of that substance, because once I change the pressure or the temperature, now it's not going to take up the same amount of space. I know if I push on a gas more, then it's going to become smaller, it's going to compress, and if I heat it up, it will expand, get bigger. If I cool it down, right, it will get smaller. So I'm going to have to set up my stoichiometry, but I'm going to stop at a point that we normally don't stop at. And let me show you how it's going to look. I'm given 55 grams of oxygen gas. Okay, so we're still working with the balanced equation from up here in number 1, and I'm going to put 55 grams of oxygen gas. Oxygen gas is O2. And then I set up my stoichiometry problem. So let me set up my grid, and I'm at grams is what I was given, so I need to figure out my grams of O2 for 1 mole of O2. So what I'm going to do here is I'm going to figure out how many grams of O2 I would have in 1 mole, since the mass of oxygen is 15.999, which I know from my periodic table. I just do that times 2, so I know the mass of O2 is 31.998. So 31.998 grams of O2 would be in 1 mole of O2. Now I can compare my number of moles from the actual equation. I have moles of O2 on top, so I want moles of O2 on bottom. Here I have 1 mole of O2, 1 mole O2, and it asks me how many liters of water. So I need to get to water. So here's water, H2O, and I have 2 moles of H2O in my equation. 2 moles of H2O. Now, normally I would go ahead and do my next step out, where then I would turn my moles back into grams or liters depending on what it was asking me for. However, I can't say that 1 mole of H2O is going to be 22.4 liters here because it's not at standard temperature and pressure. So at this point, I'm going to stop, and I'm going to multiply out 55 times 1 times 2, which gives me 110. And then 31.998 times 1 is still 31.998. So I'm going to plug this into my calculator. And I get 3.4, and I'm going to round this. The 7 will make this round up to 3.44. Now look at what unit I just got. My grams of O2 cancel out. My moles of O2 cancel out. And this told me moles of H2O. But it doesn't ask me to solve for how many moles of water. It asks me for how many liters of water. But what I did, I stopped here where it told me the number of moles, because then I can plug my moles into the ideal gas law equation. Remember our PV equals nRT from the other worksheet. So now I know N, I know the number of moles of water, and that's what I've just solved for. So I can stick my N here. I know my pressure and my volume. I don't know the volume. That's what I'm solving for, is how many liters. I know the pressure. I'm solving for volume. I know my number of moles now. R is always my ideal gas constant, and it gives me the temperature. So now I can plug this into PV equals nRT. So my pressure, it tells me here, pressure of 12.4 atmospheres. So 12.4 times my volume. I don't know, because my volume is going to be how many liters. So I don't know my volume. Equals N, 3.44, right? Which is what we just figured out, times R, which is always 0.0821, and times temperature, which 85 is degrees Celsius. I always have to use Kelvin for this, so I need to do 85 plus 273 to get it into Kelvin, which will give me 358 Kelvin. Then I'll multiply these three together, divide by my pressure to solve for volume, and you'll have your final answer here. Again, remember, whichever one it is you're solving for, leave it on its own on one side of the equal sign, bring this over and divide. So this will come over and you'll divide by 12.4. So multiply these out, divide, and you'll have your volume of water. So again, if you're not at STP, if you're not at standard temperature and pressure, stop your stoichiometry problem once you've solved for the moles of the substance you're looking for. Plug it into PV equals nRT, the ideal gas law formula, and then solve for your volume of that substance. Now this one here is still at STP, but in other problems that you'll do on another sheet, you will have to use the PV equals nRT. And this one's not done. Don't forget, you have to multiply out and divide to get your final answer. If you do still have questions though, please feel free to ask.